What's up, y'all? And today we're gonna go through another video in inorganic chemistry. So we have two structures here, and they are specifically metal complexes. And in this video, we're gonna determine what ligands are X, L, and Z. Z is very rare, and so we're gonna just focus on X and L for now. So when you look at this ligand, these two ligands, what do you think of them? When you look at these two ligands, what do you think? Immediately, I can determine that this is X because in a previous video, I explained that when you have, I listed halogens as an example of X-type ligands, but I labeled the halogen as an X. This is an X-type ligand. Why is it an X-type ligand? Because it donates a single electron to the metal center, whilst the metal center also donates an electron in order to form a dative bond. The same I can say for the chlorine, but in this case, when we look at the nitrogen, this is an L. When we look at this one, it's also an L. Why is it an L? Well, you have to look a little deeper in the molecule. Look at the electron configuration. Look at the valence. Look at the valency of the nitrogen. The nitrogen has a valency of five electrons. So this is a double bond, so there's two contributed by the nitrogen here. There's one contributed by the nitrogen, and then there's also another one contributed by the nitrogen, leaving a valency of one available electron for reactivity. But so if this is 1 and nitrogen has a total of 5 and all its other valence electrons is used, then how many valence electrons is this? It's 2. It's 2. So that means that there's two electrons being used to form this bond. The same thing here, because you have 4 valence electrons being used up in bonds, leaving a single radical for reactivity. But the bond which was formed here was formed as a result of the lone pair being donated to the metal center. So this is L. Hope this was helpful. So we move on to this example of we have 2 oxygens and nitrogens and methyl groups. So immediately I can refer this to be X. This is X. Based on what I already discussed, this would also be X. This is X, and this is X. So let's go into it. This is X. The methyls are X because they donate 1 electron. There are no other lone pairs on this methyl group. It only donates 1. And it has a valency of 4. So there's 3 electrons which form bonds with hydrogen, and there's 1 electron that forms a bond with the metal. So its valency is occupied, it's saturated. The same we can say for methyl. And so there's only 1 being donated to the metal center. When we look at the case for nitrogen, nitrogen has 1 bond here, 1 bond here, 1 bond here. That represents 3 valence electrons being used, which means that there's a lone pair here. Because this lone pair constitutes 2 electrons, 3 plus 2 is 5. So then that means that nitrogen has a valency of 5 in this case, but there's only 1 being contributed towards a bond. If you can see here, there's a metal and then nitrogen connected by a bond right here. Okay? And then when we take the case of oxygen, in this case, oxygen has a valency of 6, right? So there's a lone pair here, there's a lone pair here, there's a lone pair here, there's a lone pair here. And so there's 1 electron that is contributed to the metal, 1 electron contributed to this aromatic ring. That's why it's X, because there's only 1, not 2. When we count them all up, there's 1, 2, 3, 4, 5, 6. So oxygen has a valency of 6, it's saturated, so this has to be an X. It cannot be an L because it's not 2 electrons being donated directly to the metal center, it's just 1. So it's labeled as an X. The same we can see for here. This would also be an X because it has 2 lone pairs available and only 1 is being contributed to the metal. Hope that was helpful in distinguishing between X and L, excuse me. But that's pretty much the end of this video. Please like and subscribe. Comment in the comment section if you want to see more examples, if I need to clarify anything for you to understand. I sure hope this was beneficial in you determining how to differentiate between X and L, and I'll see you on the other side. Bye for now. Thanks.